Okay, everyone, so we're going to look at writing the ionic equation now. So, the net ionic equation. So the ionic equation, remember, is where we take everything that is aqueous and we separate it into its respective ions, right? So we have our lead 2 nitrate, potassium iodide, and potassium nitrate. So what the net ionic equation means is we're now going to cancel out or get rid of what are called spectator ions. So a spectator ion is an ion that is both on the reactant and product side of this reaction. So you'll notice here I have 2 nitrates, for example, and the product side also has nitrate. So we can cancel that out. So these are called, so what we're doing is we are canceling the spectators. Okay, so our nitrates are gone. So the next piece is looking for, obviously, what else we can cancel. So lead, notice lead I cannot cancel because on the other side it's part of our precipitate. However, our potassium is another spectator ion. It's found on both sides of the reaction. And actually that ends up being everything we can do. So the net ionic equation is actually taking your ionic equation and rewriting it out with everything that you've canceled gone. So we're going to rewrite our ions that are remaining. And of course, we have lead 2 iodide as our precipitate. So the spectator ions you get rid of, the net ionic is rewriting that out with them removed. Okay, let's look at another reaction here as an example. So write the balanced chemical equation, the ionic equation. Sometimes this is also referred to as the total ionic equation, just so you're aware. And the net ionic equation, so when we have solutions of potassium nitrate and sodium chloride being mixed. Okay, so we have potassium nitrate and sodium chloride mixing. So this is going to be, of course, it's a double displacement reaction. We have KCl and sodium nitrate. Okay, so both of these, when you check them on the solubility table, they are aqueous. So this is our balanced chemical reaction. So our total ionic equation, we're now going to take everything that is aqueous. Oh, and it's already balanced. Should have mentioned that. You want to make sure that they're balanced. So we're going to separate every aqueous compound here into its ions. So we have potassium ions and we have nitrate ions. We have sodium ions and we have chlorine ions, arrow. We have potassium ions plus chlorine ions. Then we have sodium ions and nitrate ions. So remember, only the aqueous substances get split up. If you had a solid, a liquid, or a gas, you would not be separating the ions out. So in this case, our net ionic equation, right? So remember what we're doing here is we're going to cancel out ions that are on either side. So here we have potassium and potassium, nitrate and nitrate, sodium and sodium, chlorine and chlorine. So actually there is no net ionic equation. And this should actually make sense. If you remember the 3 ways that we can have a double displacement that actually has a visual change, it's either a neutralization, a precipitate is formed, or gas is formed. So actually this is a case where none of that criteria is met. So you would simply write no net ionic equation. Okay, so give these 2 reactions a try. So we tend to use this type of reaction writing when it comes to double displacements, but just so you're aware, you can also do this with any other type of reaction. Okay, so for A and B, I want you to write all 3 reaction types: the balanced equation, the total the total ionic equation, and then the net ionic equation. So pause the video, give these a try. Okay, so let's take a look at A. So we have calcium bromide. So we have solutions of, right? And then we have ammonium carbonate. Okay, so when we do our double displacement here, we have calcium carbonate and we have ammonium bromide. So of course, when we balance this, there should be a 2 in front of our ammonium bromide. And if we take a look at the data table, you should have calcium carbonate as being a solid and our ammonium bromide as being an aqueous solution. Okay, so let's double check on the solubility table just to confirm that. So here is carbonate. Calcium is not in group 1 and it's not ammonium, of course, so calcium would go under the bottom row, which is our low solubility. And then we have, of course, bromine with ammonium. Ammonium would be up here, so that's high solubility. So there is our balanced chemical equation. So now we're going to do our ionic equation, or total ionic equation. So everything that is aqueous, we are going to separate into their ions. So we have calcium. Remember, you must put the charge and the state. If you do not put your charge or your states, you will get marks deducted. The whole point is we're trying to represent the ions, which means you have, of course, the charge. And just like with everything else in an equation, you need to have the states. So we have calcium with 2 bromine plus 2 ammonium ions and carbonate. Okay. So then we're going to have here calcium carbonate we are going to keep together because it is solid. And then we have again 2 NH4 plus AQ plus 2 bromines, AQ. Okay, so for our net ionic equation, we're going to look to see if there are spectator ions that we can cancel. So we do have some. So our bromine we can cancel and our ammonium we should cancel. By the way, you should always have the same number of ions on both sides. If it hasn't been balanced, that's the only reason why you would not have the same number, is if you did not balance that properly. So our net ionic equation is going to be calcium ions plus carbonate ions, making calcium carbonate solid. Okay, so looking at part B, the second reaction, we have zinc metal that's placed in a beaker of copper 2 sulfate solution. Okay, so let's take a look. So for part B, we have zinc in a copper 2 sulfate solution. Okay, so here we have a single displacement reaction. So zinc is going to displace copper. So we have copper on its own, and then we have zinc sulfate. So zinc sulfate, we would check the solubility table. So zinc is going to be aqueous with sulfate. So it's going to be AQ. Okay, so then of course, actually it's already balanced for us. Okay, so our total ionic equation, we're going to take everything that is aqueous and separate it into its ions. So remember, solid, liquid, and gas, we keep them intact. So we're going to have zinc solid, copper ions, plus sulfate ions, arrow, solid copper we're not touching. Then we have zinc ions and sulfate ions. Okay, so at this point, right, for our net equation, we are going to cancel spectators where possible. So remember, solid zinc is different from aqueous zinc ions. You cannot cancel those two out. So really the only spectator that's here is sulfate. So our net ionic is going to be everything written out as is, except with our sulfate removed. Okay, and that is essentially one way of looking at reactions in solution. So you have your ionic and your net ionic equations that are now new from this lesson.